Morning. In this lecture video, I will be discussing the sample distribution, module number 5, but we will focus on the types of random sampling. At the end of the video, we will be answering some questions, review questions related to our previous lessons. Start off, concepts and description. We've discussed this already in class. So we know we have different methods of data collection, but the most frequent method that we use is the sampling method, okay? Which, as discussed in class, is a measurement of a part of a population. Now, this is what we often do because conducting research in a big population is often more difficult to carry. So we try to focus on certain samples only. We also solve for the following variables, the mean, variance, and the standard deviation after gathering the data. One of the variable that we solve often is the sample mean and population mean. If you're looking into a small group, a sample only, you use this equation where the x bar means the mean, the summation of x is the sum of all data values, and the small letter n is the number of data samples. If you'll notice, the population mean has also the same formula, but the x bar is replaced with the mu to signify that you are looking into the population. You'll notice as well that the symbol representing the data of items in the population is a capital letter N. We also solve for variance, and these are the formulas for the sample variance and population variance. If you'll notice, they have the same structure, same formula, but we replace the letters for the mean, x bar for the sample variance, and the mu for the population variance. The denominator, on the other hand, for sample mean, or sample variance rather, we use n minus 1, and population variance, we use capital letter N. And lastly, okay, the deviation is often determined to check if the data values are scattered, if they are um, varied, um, if they are deviated from the mean. Okay, so they have the same um, structure. So if you'll notice, remember in our previous lesson, the variance um, is the standard deviation is the square root of the variance. So given the formula of the variance, you take its square root and then you get the standard deviation. Okay? Remember how important the standard deviation is, okay? Apply the formulas presented in the previous slide. So let's say you are to calculate for the mean and variance of 5 student exam scores from a statistic course with a total of 25 students. So the scores of the 5 students are the following: 86, 70, 80, 83, and 65. So first you must solve for the mean of the data. So following this equation, since this is just a sample of the population is a 25 student class, right? But you're looking into only the 5 students in that class. So you will focus on the sample mean. So the formula is x mean is equal to the summation of scores divided by the total number of data. So you have to write down each individual score. So it's 86 plus 70 plus 80 plus 83 plus 65 divided by how many data is given to you. So 5. And then you should be able to get, if you do the math, you get 76.8. That is the mean of the 5 data given to you, or the scores of the 5 students. Now, for the variance, we just have to use the equation for the sample variance. Again, we will use the sample variance because you're only looking into the sample of 5 students in this 25 student class. Okay, so let's copy the formula. So variance squared is equal to uh, the summation of x minus mean squared all over n minus 1. So this is quite long. Okay, this is what we're gonna do. Okay, so add all the values, the scores minus the mean, and then you square each of the differences. So what is the mean again? So let's write it down here. The mean that we calculated a while ago is 76.8. Okay, so what will happen is we'll have individual brackets for each of these scores. So the first score is 86. So 86 minus 76.8, which is the mean, then you square it, its value plus, okay, the next score is 70. So 70 minus 76.8 squared plus, next score, 80. 80 minus 76.8 squared plus, next score, 83. 83 minus 76.8 squared plus the last score, which is 65. So 65 minus 76.8 squared divided by n minus 1. What is our n? 5 minus 1. Okay, input these values in your calculator. You will be able to get 79.7, okay, as your variance. Okay, here is the summary of the calculations I presented a while ago. So 76.8 for the mean, and for the variance, we get 79.7. Okay, now let's recall some parts of the lessons in the Canvas. Okay, so we have different types of random sampling. Okay, the first one is lottery. From the term itself, lottery, it's a form of random sampling where you try to pick, okay, certain data out of the given data set randomly. Okay, next, so you sort of draw data out of the data set. The systematic random sampling, you follow certain criteria. For example, you have you're trying to, your sample is one class, and you will only take the data of every odd numbers in that data. So you will take the data, the third data set, the fifth, seventh, ninth, 11th, all odd data sets only. So you follow a systematic rule when you select the data. We also have the stratified random sampling. So this is when you set a specific criteria or characteristic that you're looking into. For example, in a class or in 5 sections, you will examine the girls and the boys. For the girls, you will only examine the girls, let's say, with long hair, and for the boys with a height of 5 feet and above. So you classify them into certain strata or characteristics. Okay, so that's why it's called stratified sampling, because you set a certain strata or characteristic only, which will be your basis for the selection. Okay, And we also have cluster. Cluster is quite similar to stratified, but a cluster does not necessarily fixate on a certain characteristics. For example, maybe it's something that's common to a certain group. For example, in a faculty room, all of the um, persons inside are, of course, teachers, but the teachers inside are classified according to the cluster they belong to. We have STEM teachers, we have UMS teachers, we have ABM teachers. So they are classified into something that's common to all of them as a group. Okay? And then the last one is the multi-stage random sampling. This happens when you combine or yes, you combine two types of random sampling. For example, you have lottery sampling, and then from that lottery sampling, you divide them into stratas, or maybe you first divide the data into or classify them into different strata, and then you proceed by drawing um, data out of those strata. So you combine stratified and lottery random sampling. Or maybe you could combine stratified and systematic. So you have different strata, and then you are going to select systematically by um, getting only the first, the even data or the odd data. Okay, so that's it for the types of. Let's try to answer an example here and identify whether the problem represents a sample statistics or a population parameter. The first one, okay, a recent survey of a sample of 450 college students reported that the average weekly income for students is 325 pesos. Now, the clue, if you will read the statement, there is already the term sample and a number. Okay, so the 450 college students is just a part of a population. So obviously, the number here is just a part of the number of enrollees in a university. And so this one is a sample statistics. The second one is the average weekly income for all students is 405 pesos. So the term all students, the words all students represents that the data 405 pesos is referring or was taken to from the population. Okay, so the answer is population parameter. So let's identify the sampling method applied in the following situations. So say a sample of 10 mice are selected at random from a set of 40 mice to test the effect of a certain medicine. So, for example, you have this large container with 40 mice. You will try to randomly select 10 mice. So, it's like drawing, okay, an object or a mouse from the set or the box. So, since it's like um, randomly taking an object, it's somehow similar to what we do when there is like what we do in lottery, right? So this right here is an example of a simple random sampling, the simple drawing or taking of data from a data set without any criteria, any system that is followed. Okay, how about the next? A barangay health worker asked every four house in a village for the ages of the children living in those households. So it says every four house. So this does not necessarily mean a characteristics or a group that the households can be classified into. Okay, so it's just simply stating that in a barangay, every 4 house, okay, the health workers will assess the age of the children living in those households. So it follows a system, right? So like the nth number of house. So every fourth house, it could be every fifth house, every 10th, okay? Or maybe by color in the next yellow house, they will interview and so on and so forth. So this is a systematic sampling. The third, okay, the teacher randomly selects 20 boys and 15 girls from a batch of learners to be members of group that will go to a field trip. So it specifies that boys and girls will be selected. Okay? So these the data are actually based on a set of characteristic or by gender. Okay? So the data will be coming from a group that is classified by gender or a strata. Okay, so this is an example of a stratified sampling method. Okay, okay. Now this time, let's try to compute for the x-scores of the following numbers. Okay, remember that the x-score is computed by adding the mean and the product of the z-score and the standard deviation. Okay, so this is the mean, z-score, this is your standard deviation. Okay, so let's start with number 1. Since all values, mean, z-score, and standard deviation are given, all we have to do is to substitute. So the mean for number 1 is 102.63 plus the z-score, negative 2.08 times the standard deviation, 15. Okay, you may pause the video to solve for a while. After solving, you should get 71.4. All right, for number 2, okay, direct substitution as well. Your mean this time is 283.39 plus this z-score, which is 1.72, multiplied by the standard deviation, 28. The answer is, pause the video, 235.23. Okay, so it means that the score in this corresponding z-score is 71.4, which is a bit far from the mean given to you. On the other hand, in number 2, the x-score is 235 from from an area of a z-score 1.72. Okay, and this score is also far from the mean, which is 283, because obviously the scores are deviated. Okay, the deviation is 28, so it's reasonable. For the last problem, okay, this is a complete math problem. For example, a company has decided to accept 15% of their examinees. The test has a mean of 150 and standard deviation of 20. Look for possible lowest score for an applicant to pass the step of application. So you're looking at the lowest possible score. So you are also solving for x, and this x value represents the score that the lowest possible score that an applicant must get in order to get into the company. Okay, once the applicant gets or achieves this x score, or maybe more than this x score, he or she belongs to the 15%. Okay, so first write down the given values. So the mean, as stated, is 150. The deviation is 20. Now, what is missing? It's the z-score, right? Remember that the score is determined by the mean plus the z-score times the standard deviation. Obviously, the z-score is not given. So how will you get the z-score? You have to solve this first before you get the x score. So remember that the company will accept 15% only of the examinees, and you are to determine the lowest possible score that an applicant must get. So it means to say that out of 100%, okay, they must get about the difference of 15% and 100%, that is 85%. Okay, so in percent, they must get about this rating. But what is the score that an applicant must get in order to have 85%? So we convert this into decimal. So it would be 0.85. So if we will assume that the data is a normal curve, it means that only the highest 15%, okay, so the highest, out of 100%, 15% would be accepted, so somewhere in the positive. Now then, you take this area, okay, and locate it in the table to determine what is the z-score. Okay, so once you look at the table, okay, the 0.85, the z-score closest to 0.85 is 1.04. Okay, let's just erase the right things. It's actually 1.04. That should be the value that you will get out of the table. And then you will now take this value and use it into this equation. Okay, so the result would be substitution of 150 plus the z-score, which is 1.04, and the standard deviation, which is 20. Okay, doing the math, you should get 170.8. So meaning to say, the applicants of that company must obtain at least a score of 170.8, okay, in order to get into the company. Okay, so that's one of the applications of the x-scores and why we solve the x-score. That's it for this video. Our next lesson would be sampling distribution of sample means. Good luck in your exam next meeting. Goodbye and thank you, students.